right, let's do this. Welcome to the Backyard Professor live show. I have no idea what's up with this double screen stuff. This is freaking me out. One is a vertical, one is a horizontal. I know there's two of these on my website. I hope you can all see me. I'm going to go ahead and do this. Here we go. So, tonight's going to be a fun night. I just want to note, as a way of letting you know, there is a book. Now, this is new to me. It's not a new book, but The Ring of Words, Tolkien and the Oxford English Dictionary. Did you know that Tolkien worked for the Oxford English Dictionary for a few years, right fresh out of college? And that's how he became an absolute world-class philologist. He worked in about a dozen languages. Welsh and Finnish were his most important ones for his work on the Silmarillion, the Lord of the Rings, the Hobbit, etc. I've been doing some Tolkien study, getting some more materials, and it is sensational. I am in the process of putting together a handbook on Tolkien. So if any of you know who any Tolkien readers are who love Tolkien, let me know. If any of you are, within the next month or so, I would like to have a manuscript to be able to share with you, to put another pair of eyes on it and give me some peer reviews. So anyway, welcome everybody. Cynical Banana, Tim Wagner. My eyes are blurry as all get out tonight. I've got to get to the doctor to get my new glasses. Other Sheep, how you doing? Tim Rathbone, Oregon Squatch. Good to see all of you. Comic stuff. Hey, now that's what we like, comic stuff. Debbie Donovan, Aaron Clark, Al Bundy. Good to UFO Busters, the UFO show from Australia, coming at us from down under. Here we go. Okay, good to see all of you. Tristan Jones, hello again. Renee Phelps, good to see you. His Highness, good to see you, my man. We're going to do some science tonight, my Highness, so stick around. You can check my math and physics. Yeah, baby. And then Cole Carlson, good to see you. Yeah, I know. I got to get my eyes fixed. I've got a boatload of reading to do, Tim. I've got to get serious and with it. Listen, fresh off the press, no joke, today. Now, it was 3 hours ago as I saw this. So now, and when I saw it, it was 4 hours old. But this is, for more or less want of a better way to put it, breaking news I'm going to share with you tonight on 3i Atlas. So, hey, Joe Burnham, good to see you. Christina Spearling, hello, hello. AR12, yo to you too, Bubba. Good to see you. Benjamin Manning Music, woohoo! Love you too, man. Okay, so we're going. I've got a response. I've actually got a couple of responses. Avi Loeb has a fresh new update today, Sunday, on 3i Atlas I want to discuss. And one of my good buddies, I consider him a good buddy. He probably doesn't even know I exist. Well, he does know I exist. He's given me a shout out before. But the Angry Astronaut, whose website has just taken off, man. His YouTube videos, he has lots of people who love what he says. And I'm going to analyze his most recent today discussion on 3i Atlas. Hey, Mark, good to see you too, buddy. Okay, so what I want to do is do a response video tonight, not in the way of tearing down or beating up or telling them to grow up and let's do this right, because they are doing it right. That's right, you heard me. I am saying Angry Astronaut and Avi Loeb are doing it right in their analysis of the 3i Atlas. I have some nitpicks to make, which I will do so, but I also have some praise for both of them because, let's face it, this 3i Atlas thing is really kind of exciting, especially now that it's going to get really, 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 really close to our Earth. Should we be scared? No. On the universal scale, if we were out there a billion light years away and looking, it would look like it's going to hit us. From our vantage point, it's going to be 170 million miles away. There ain't no way in diddly lick spittles that it's going to even graze us. There is no chance, none, zero, impossible that it's going to affect us at all physically. So I just want to clarify that. So for all those video makers who are terrified, good, I hope you poop your pants and you stink for a week, because it's all for nothing. You obviously don't understand the physics involved with this thing. You're not watching my channel. All right, let's get on with it. I want to respond to my friend Angry. And his new video today was really about a half hour. It was good. I want to do a claim by claim analysis. He says the anti-solar jets that only managed to make it out to about 60 to 80 kilometers, not hundreds of thousands of kilometers, the wind shear from the solar wind matching another comet, UN 271's wind shear, is the real halo at this distance. So here's my analysis, and I have to confess something, and I'm going to say it out loud, because I really enjoyed it. It was a couple of videos ago where Angry was utilizing Grok, the AI of Elon Musk, and he did some analysis with Grok that I thought was very interesting. If we will utilize AI as a tool, not as a final answer, if we can utilize it as a tool, it is quite seriously useful. What I used my AI for today to check up on both Angry Astronaut and Avi Loeb is it can search wider and deeper across the internet 1,000,000 times faster than I can. That's what I used it for today. I asked it to go look up the astronomical societies and their analysis of 3I Atlas, and I asked it to go to the scientific places that discuss 3I Atlas all the way up to today, and let me know what has been happening for the last week of analysis of 3I Atlas. This is my response. I asked it questions, it gave me this response. So this, hey, Claudia J. So this is really quite fun. For me anyway, because this is what AI can be used for legitimately. I realize there's people who are so terrified of anything non-human that they refuse to touch AI. It's all good. I'm not trying to convince you to use AI. I'm telling you, I'm using it with beautiful effect here. So this claim is that the comparison of this comet, UN 271, that Angry Astronaut does, this is the comet that was found or seen by Bernardinelli and Bernstein, the UN 271, that sunward jets only extend 60 to 80 kilometers under the conditions that it is right now. I found no peer-reviewed publication that states sunward jets or anti-tails only extend 60 to 80 kilometers for this comet, UN 271, the one that Angry Astronaut is comparing to our 3I Atlas. So instead, what was discovered at Farnham et al., they note that the sunward enhancements from large, slow dust grains, but they don't give a hard 60 to 80 kilometer limit. It also claims wind shear, Angry Astronaut claims wind shear from the solar wind would destroy jets at 1.4 astronomical units, so they would not reach hundreds of thousands of kilometers. So the idea here is that while solar wind and radiation pressure certainly does affect the comets, and those effects are real, that's true, the simplistic wind shear shreds it argument of Angry Astronaut is not supported by detailed modeling that I found. So his comparison, his philosophy of comparing is superb. This particular comparison with the claim of a 60 to 80 kilometer limit is not near as good as it could be. The claim is inaccurate and or misleading. Now, this doesn't make Angry Astronaut all of a sudden a villain or a bad guy. I'm just saying I don't agree with his idea of the comparison. For this reason, the number 60 to 80 kilometers is too specific without clear evidence. And the wind shear destroys 100,000 kilometer jets argument oversimplifies the physics. It's not a crisis, it's just a disagreement. So one of the other claims that Angry Astronaut makes, he says, in other words, the only thing we're seeing at 1.4 astronomical units is the natural halo surrounding this comet, not any kind of anti-solar jets. For 3I Atlas, at 1.4 astronomical units perihelion distance, that is the closest to the sun, multiple observatories reported both the sunward, the anti-sun features, and the long tails, that is the dust and the ions, extending huge differences like hundreds of thousands of kilometers. Huge. But they did detect anti-sun tails on 3I Atlas. For example, images captured show a well-developed ion tail and a sunward fan, that is pointing toward the sun, which, according to other comets that we've seen, is not supposed to be happening, but it is with 3I Atlas, and it has with other comets as well. So some features extend 100,000 kilometers. That's true. That's very good. To claim only the halo is visible, however, and no anti-solar jets ignores this. And it conflicts with the observational literature. So I disagree with that part also. This claim is inaccurate. That's the conclusion. So here's another claim that I want to discuss. Another natural example is C2017K2. Now, this particular comet exhibited highly columnated CO-driven jets extending over 100,000 kilometers at distances of 10 to 15 astronomical units with minimal rotational blurring. So the interesting thing is the rotation period of this comet is 57 days, not 16 hours. So it's not a good analog for 3I Atlas. He's saying that the comparison of this comet K2, because its rotational timing is 57 days, unlike 3I Atlas, which is only 16 to 19 hours, which is so much faster that you can't compare the two. That's the claim. And it's a good claim if it was true. The comet in question is likely C2017K2 and is indeed showed activity at large heliocentric distances, that is, distances away, 20 astronomical units to 10 astronomical units. That's a long way away, so that's good. I found a 2022 paper Jewett et al. That estimate its nucleus rotation period not at 57 days, like is claimed, but 20 to 30 hours. So the 57 days claim is highly suspect of angry astronaut. Just to understand that. Now, there's a broader point here. Analogs for 3I Atlas should ideally match rotation period and hence the caution in analogy. It should match rotation period and the environment. And the transcript correctly points out that K2's environment is a very different environment, hence the caution in analogy. So this is a plausible argument. Good job, Angry. But the data, the 57 days rotation, is just wrong. It's not that, and so his claim is weakened. The rotation is 20 to 30 hours, which is vastly closer to 3I Atlas's rotation period of 16 hours, so that the analogy here could be very, very good. Angry has thrown this comparison away because of a disputed rotational period, and his claim is not accurate. Therefore, you can say you're partially plausible. This isn't a right or wrong. We're just discussing things. The logic that it's not a perfect analog, well, that's true, but the factual basis of 57 days is what's inaccurate. With 20 to 30 hours, it's much closer. So here's another claim that I want to talk about. He says, we have never seen examples of these sunward facing columnated jets before. This is such an amazing and unique opportunity about an object that does differ radically in so many ways. This object, 3I Atlas, whether it's natural or not, is displaying things that we have never seen in nature in the past. That's his claim. The idea that the jets of 3I Atlas is pointing toward the sun against the solar wind coming from the sun, the jets should all be behind 3I Atlas. But it's got jets that's pointing toward the sun. Look, that's weird. He's right. That's weird. But he says we've never seen this before. And is that accurate? No. We have seen sunward features, in other words, anti-tails in the comet UN 271 and some other comets. So never seen before, that's a false claim. That's not true. It is correct that 3I Atlas is unusual. Absolutely. Well, the thing is interstellar for one thing, right? It's got high eccentricity. There's no question there. It does have strong jets. It does have a large nucleus, and I'll talk about that here in a few minutes. Absolutely. But this does offer a unique opportunity. All of that is correct. We don't disagree with that. But the claim that things we have never seen in nature, that claim is overstated. There are precedents to this. The magnitude and scale might be larger than most, but never is too absolute of a stance. So this claim is inaccurate or misleading in its absolute phrasing. The object is unusual, but it's not utterly unprecedented. So we move on to the next claim. He says, less and less likely to me that this is natural, given the things about this object's trajectory that definitely seem to be extremely useful for someone that might have sent it here by design. And he's got a point. But the reference to trajectory is likely that 3I Atlas has a hyperbolic excess velocity. It enters from interstellar space, right? But calling that extremely useful for someone that might have sent it here by design, that's just speculation. That's not the science. It's not a tested scientific claim. So all of the major agencies that we looked into and the papers treat the trajectory as consistent with an interstellar comet, not a probe. That's the bottom line. So this is speculative rather than supported by evidence, his claim that it could have been sent here by design. It's reasonable to mention alternative hypotheses. We're not saying quit mentioning alternative hypotheses. That's not the stance. But we treat them as strong inference. That's what's misleading, because it's not strongly inferred that it was sent here by design simply because it's got a couple of anomalies. That is where the speculation comes in. As long as we label it speculation, we're good to go, right? So another claim that Angry makes: if we continue to stubbornly insist that these objects must be natural until it's too late, it could lead to a very tragic end to our civilization. I mean, good God, don't make that mistake. Well, obviously, this is a rhetorical flourish rather than a scientific claim. So there's no credible evidence whatsoever that 3 High Atlas poses a threat, or that by ignoring the non-natural scenarios gives us a risk to our civilization. No, this claim is unfounded in the scientific record. So here is the status of the claims that I discuss out of Angry's brand new video today. The jet travel time and spacing math is accurate for the given assumptions. That was good. Jets should be smeared by rotation, and because they're not, therefore they're thrusters. That is physics oversimplified with an unsupported conclusion. When you compare the other comet, the UN 271, that only had 60 to 80 kilometer jets, that is inaccurate and misleading. And the only halo seen at 1.4 astronomical units with no anti-jets is inaccurate. That's not true. The K2 rotation being 57 days is a bad analog. Well, that has inaccurate data and plausible logic. So the idea of never seen sunward columnated jets before is also inaccurate and misleading. And finally, the trajectory implies divine is a speculative inference unsupported by the data. And ignoring the natural hypothesis causes the civilization's end, which is pure hyperbole. It is unstated scientific basis, and it's fundamentally not worth spit, to put a blunt point on it. So now the AI advises me, here's how you might structure your reply. Acknowledge the math. And I do, because I had the AI work through the math also. It's really good math. That's legit good work. So you're killing it on the numbers, but highlight the physics caveats. As with many things in comet science, the model used, such as the single vent and the fixed speed and no geometry and no mixing, all of that is oversimplified. The real comet jets are messier, and the rotation axis plus the viewing geometry can make a stable jet appear straight, even if the nucleus is spinning fast. Now, that's what we call cooking with nuance, right? So we have seen sunward features and anti-tails in the comets. Hello, UN 271. That one has them. So saying never before, that's not accurate. That's not weak. It's just not correct. That would rock to admit instead of overshoot like that. So this interstellar visitor is fascinating without question. And no joke, it is a one of a kind in our observation so far. So this should excite us, absolutely. But jumping straight to the idea, there are anomalies with this thing, therefore thrusters and engineering and intelligence behind this thing, mothership of alien UFO beings who are alive and have arms and legs like us. Not a chance. No and hell no. Not even close. The science doesn't even begin to get to where we can get on the edge to even take that leap yet. So let's keep the hypothesis sandbox open, not locked. So my take, 3I Atlas is a huge CO2-rich interstellar comet. Very unusual in scale and behavior, without question. And this is opening the door for us to learn about other planetary systems. There's your thrill right there. This is an interstellar visitor. We don't get these very often. That's pretty damn unique and groovier than groovy. But since by all takes, we really don't even know up to 4% of our universe yet. We ought to be a little bit humble if there's several different anomalies of something that comes from millions of light years away. Of course, it's going to be different than anything we've seen only from our neighborhood. That makes perfect sense. So the rule is be prepared for surprises with the honest recognition and the scientific reality that anomalies do not equal UFO. Anomalies show us our own ignorance and get excited about learning something spectacular about our universe that we've never seen before. That's the juice. Would be my option. So now I want to do a clear response to the claims of Avi Loeb. And I'm going to put, I'll put the links to both Avi Loeb's analysis and the Angry Astronauts in my description below this video, because they really are good responses. They're fun. It's interesting and exciting to see how people are analyzing this stuff, right? So I want to, I've already done this. Right, hold on. I've already done this one. I wrote it out. Sorry. Let me get to Avi Loeb. That's Angry Astronauts stuff. And okay, this is the Avi Loeb analysis. Some people think this might be a natural comet. Some people think it might be something more exotic, maybe even artificial. And the truth is, we don't know yet. That is true. We don't. But what we do have at this point is a mountain of data. We've got some chemistry. We now have some images. We have some spectra. We have jet directions. We have weird behaviors. And we're going to walk through all of that to look at it tonight. Here we go. The anti-tail. That is a tail that points toward the sun. We have a new telescope image from Thailand. Yes, and it shows 3I Atlas with a strange anti-tail, a bright line pointing toward the sun instead of away from it. That's unusual, but not impossible. So the natural explanation is a giant dust grain type approach, about 100 micrometers across, about the width of a human hair. These big grains are 1 million times heavier than the tiny ones that most comets do release. Big grains don't get pushed away by sunlight easily, so they can form a sunward streak. The natural explanation number 2, ice chunks that evaporate before the sunlight can blow them into a tail. So the chunks shine for a while and then they disappear, leaving no big classic tail. Now, these are normal physics. The artificial explanation, and this is Loeb's speculative option, is maybe this is a jet from thrusters like engines firing gas backwards at high speed. This is allowed to stay on the table, but not treated as proven yet. It is pure speculation. With natural possible explanations, the thrusters idea is much, much weaker, just so you know how this works. So he talks about the dust size versus the brightness of this fabulous comet or interstellar object. And here is the key science. Tiny dust particles reflect sunlight well. Big dust grains reflect sunlight poorly. Okay, so to make the anti-tail as bright as we see it, 3i Atlas would need a lot of big dust grains. This is Avi's argument. Around 100 times more mass than a normal comet would need. And that's odd, according to Loeb. Now, astronomers think that it is interesting, but it's not impossible, just so you understand. So the idea of jet speed as a test, Avi says, he proposes a clean scientific test. So here we go. Avi Loeb is proposing a scientific test. This is good news. This is what we do in science, folks. So this is good. Natural comet jets blow gas at hundreds of meters per second. Artificial thrusters shoot gas at thousands of meters per second. So if we can measure how fast the material is leaving the comet, we can tell the difference. Now, this is actually a good idea. This is fantastic. We'll get those measurements in December when it's closest to our Earth. This is how science works. Right now, nothing shows these superjets. Hopefully in December, we can get enough data that we can check that. That's awesome. So then Avi moves to the idea of the missing tail. So when 3i Atlas passed closest to the sun, the perihelion, it should have a giant glowing tail of dust and gas, but it doesn't, and it didn't. So we just see a fuzzy ball, which we call the coma. So, and there's no long streaming dust tail behind it. Comet Lemon, photographed 2 days earlier using the same telescope, did show a normal tail. So this raises a real scientific question. Where is all the missing material? Is how Avi Loeb is asking this. If Atlas lost 13% of its mass, we would naturally expect a very huge tail. Yes. Since we don't see one, what are the possibilities of an explanation for this? Maybe it didn't lose that much mass. Or maybe the material is unusual, say like big grains or else ice chunks or gas with no dust. It is interstellar. There are a trillion different possibilities. The tail is pointed directly along our line of sight, or Loeb's speculative option, thrusters instead of natural outgassing. Astronomers are currently thinking that the first three natural explanations are far more likely, but we'll find out more as we continue exploring it, looking at it, and it gets closer to us in December, hopefully. So the Europa Clipper flyby opportunity. The Europa Clipper happened to pass through the region where Atlas's ion tail might be. This could be good. If Atlas is a normal comet with a huge mass loss, Clipper should detect charged particles, magnetic fields, ions in the solar wind. When Clipper publishes its data, we're going to know more. This is real science. Avi Loeb is proposing real science here. This is good. Another idea is the James Webb Space Telescope chemistry. CO2, CO, and water. James Webb gave us solid chemistry. CO2 to H2O ratio is about 8:1. So, and this is very unusual. There's no doubt about that. It is. Most comets are water dominated. Atlas is CO2 dominated. Well, what are the possibilities for this strange state of affairs? It formed in a very cold region of another star system. That is incredibly likely. It was processed by cosmic rays over billions of years. Again, since it is interstellar, we have no idea how far away it came from, but we know it wasn't in our region of space. Then that's a possibility. These surface layers are burned crust, not original interior material. This explains a lot of the weirdness of 3I Atlas. So people who were saying, well, this thing is defying normal cometary physics, don't know what they're talking about, because this is not normal cometary physics. This thing is a visitor from a place we have no clue about. Its composition, its structure, its chemistry, nothing. So we're guessing, which is yet another reason why we really have to depend on the data. That's critical. And Avi Loeb is right there saying so. Yes, this is how it's done, folks. Okay, this idea of cosmic ray processing. So, what are cosmic rays? They are high energy particles in space, and they're everywhere. These rays can turn carbon or CO into CO2. They can create organic crusts. They can redden the surface. They can change the first 15 to 20 meters of material. And all of this fits perfectly with what we have observed so far with 3I Atlas. Atlas is very red. We are aware that it is changing colors. Absolutely. The supposition there is that the perihelion run around the sun caused maybe cracks in it, or possibly blew away some of the material, and there is a different gas coming out now instead of the one that we saw on its way toward the sun, right? It can create organic crusts, it reddens the surface, and it changes the first 15 to 20 meters of material. Atlas is red, CO2 is extremely high. The water is very low, although I've seen some reports, I don't know how valid they are yet, but I have seen some reports that now there is a lot of water coming off of 3I Atlas. I'm keeping my eye on those. And metals like nickel behave oddly, which is what we've seen. This is a strong natural explanation, as Avi Loeb has indicated. Absolutely. The red color and metal chemistry. Atlas is redder than most comets. It's similar to outer solar system bodies like the Kuiper Belt objects or the Centaurs or the D-type asteroids. Nickel is very high early, iron is low, but this rebalances as it warms up. interestingly enough. This is normal for very cold ancient objects. Nothing here points to technology. There you have it. The size and rarity. Now, this is very interesting. And I'm gonna give you my slide right now on this, because this is worth looking at while I'm talking. You want to look at this instead of me anyway. So let's take a gander at this. Oh, I'll leave myself. You guys can read that. You guys can see that. Let me share about the size. Atlas might be between 0.25 and 3.5 miles wide. Now, that's up to 1,000,000 times more massive than Oumuamua. So, in comparison, this thing's pretty big. Loeb says, why did we find such a big one so early? Astronomers say our surveys just improved. We're seeing things now that we missed before. Rubin Observatory will answer this for sure. Is it natural? Is it artificial? What does the data say? So what we do here is we compare Atlas to Oumuamua. And Oumuamua was weird. True. There wasn't any visible gas, for instance, strange acceleration. It had a tumbling motion. It was shiny, flat, reflective surface, right? But we saw it too late. And that's why we didn't get any data on it, because of the timing here. With Atlas, it's different because we saw this thing coming a long time ago. So we're gathering huge amounts of data now. This is invaluable. This is what we want. Its chemistry strongly says comet. I cannot overemphasize that. It is Avi Loeb's conclusion here. Its chemistry strongly says comet. Its structure strongly says comet. Its jets and coma look comet-like, even though they're unusual. And so that's acceptable. This helps keep the natural explanation strong at this juncture. But the cool thing is, it's now approaching Earth closer and closer and closer. I believe it's either December 16th or December 19th when it will be at the closest to Earth. And we've got between now and then to keep gathering data, which is really exciting. That's cool. That is really cool. So Loeb's core argument is this. Here's what he says. He says that natural explanations might explain everything. Notice he's being cautious. This is absolutely properly scientific. But don't close the door on the artificial idea. Now, look, that's fair. That's fair, in my opinion. As long as we keep in mind and recognize extraordinary claims require extraordinary evidence. So far, there is no artificial structure. There are no metals or alloys. There are no smooth surfaces. There are no high energy jets. There are no radio emissions. There are no maneuvers. There are no course corrections. There are no heat signatures. There are no engineered symmetry. Atlas behaves like a natural comet, just one with odd chemistry and a weird tail. But that's exactly what we would expect from an interstellar object. So that's no surprise. That makes perfect sense. So an analogy. Now, Loeb uses a fun analogy here. This is really good. If you train AI only on Earth comets, it will always classify objects as comets, even if something is totally new. He's right. Humans need to stay open-minded too, but open-minded does not mean ignoring the data that we do have. That's critical, right? Now we have a Tesla Roadster example that Loeb talks about. Loeb reminds us that NASA once mistook Elon Musk's Tesla Roadster for an asteroid. This is true for about one day before the orbit and brightness made it obvious, but Atlas emits gas. It has ice, it has CO2, it has dust, it has organic material, and it has a natural coma and jets. It behaves nothing like a machine. And we have to keep that in mind. Truly, we can't ignore that. And we've been watching it for months and months. And there is still no odd, unnatural machine type behavior at all. That's imperative to keep in mind. So the new almost interstellar comet, another new object has shown up. C2025V1. And this also shows a nearly hyperbolic orbit and a weak tail. Well, this might show that weak tail comets are a class, not a mystery. Again, this helps the natural explanation, not the artificial one. Okay, we got to keep that in mind. The Rubin Observatory will explode the data pool, and it will find thousands of new objects every night, so that after a few years, we'll know how common weird comets really are. We'll know whether Atlas is rare or whether it's actually a typical interstellar object. And we'll understand the missing tail class much better. This is the future of comet science. So there is public excitement. Loeb mentions the teachers and the kids and the engineers and the everyday citizens, etc. They are all writing to him about this 3I Atlas comet, and that's wonderful. This is fabulous. Atlas is doing what science does best. It makes us curious. It makes us want to know more. It makes us want to study our mathematics and our physics and our astronomy. Oh, heck yes. This is the power of it all. Loeb is doing a sensational job keeping it in the public. He is good guy, scientist, open-minded, curious, willing to explore. That's the power of science right now. So we're all part of that, every one of us, right now. This is real-time science occurring, and we have a very good scientist showing it to us. Here's what's coming. Here's what December is going to reveal. Now, realize we have the JWST on this also. It's going to measure jet speed. It's going to measure the chemical composition, and it's going to measure the outflow rate. Hubble is going to look at the ultraviolet gases and the sulfur versus oxygen ratio. The ground telescopes are going to watch the jet shape. They're going to watch how the coma changes in time, if at all. They're going to watch how the brightness changes in time, if at all. The spacecraft, the Europa Clipper, for instance, is going to detect ions or magnetic fields. It's going to give a direct sampling, which is spectacular. And these will settle the natural comet versus something else. Right now, astronomers overwhelmingly lead natural, and very justifiably so. So the final message is what 3I Atlas teaches us. Here's the heart of it all. The universe is full of surprises. Now, we ought to know that. We like to think we are so smart that we pretty much know about 90% of the universe, and you're bullshitting yourself. We don't even know 4% at very best, and that's unlikely. So our models get better with every discovery. And so our cometary model, because of the fantastic cometary situation we've been in for the last 10 years, has been spectacular for upping our own game of understanding this stuff. That's beautiful. That's fantastic. Atlas is unusual. And that's a blessing. But unusual doesn't equal artificial. It never has, it never will. It means unusual. It means it's something we haven't seen before. Yeah, it's CO2 rich, red, old, and heavily cosmic ray processed. That's what it is. It's the oldest object we've ever studied, and it's coming to within a mere 170 million miles of us right now. That is spectacular, man. What a Christmas gift for science right there, right in our backyard. Fabulous. And it's been traveling for billions of years. This is the chance to learn. This is what it's all about. New knowledge. So as Atlas swings past Earth in December and it heads back out to the stars, we only have this tiny window to learn from it. We gotta do everything right now, super duper fast. And it doesn't matter whether its strange behavior comes from cosmic rays or odd chemistry or ancient origins, whatever, or even something we haven't discovered yet. There's one thing for certain without question. The universe is more magical than we have ever thought. And we're seeing a piece of that magic, which should whet our appetites and make us grateful for the ability of science to work and function properly. That's what it's all about. Let the data guide us, not fear, not hype, because science isn't about fear, and it's not about strange, weird, wild, hairy speculations. It's about data. As my friend Dan McClellan says concerning the Bible, data over dogma. I will put that right onto the science label. Data over dogma. And that is the juice. So that's what I have to share with Angry Astronaut and Avi Loeb. I have to say, it is a thrill learning all this stuff with them. It's really quite fun to do. It's very interesting. It's humbling, without question, because we realize that of all the things we know, none of it amounts to a hill of beans, really, considering we're just ants on a speck of dust, and an even smaller speck of dust is flying by us, and we're all giddy about that. Properly so. So that's all I've got tonight. I hope you guys have enjoyed it. I hope you've had a good chat. I don't have anything else to add. I'm somewhat tired. I'm going to head out, and I will keep bringing you Tolkien material and esoteric materials and more UFO materials and more 3I Atlas materials. Man, that's 4 groups. I'm going to separate 3I Atlas from UFOs. 3I Atlas is not a UFO. There is literally nothing to justify that type of even speculation. I'm open to it, but I go by the data because that's where the secure knowledge is. And so far, the data absolutely overwhelmingly says an interstellar object that's entirely natural, and it's following all the laws of physics so far, and chemistry, and spectra, and light, etc. It's all natural at this point. So, thanks for watching. hit the like and subscribe. Hit the notification button so that you can see when I kick out more videos, and I will catch up to you guys just as soon as I can with more information as I find it. Appreciate all of you. Be safe, do well, make lots of friends. Keep smiling, man. Life can be good when we decide to, and I have decided to.